conveys any real information. There are just so many colors. I think we've had enough of these graphs. So I think right now you get the idea. You get the idea. You know, your histograms and bar charts should be your fallback options. Almost always they would work for you. A pie chart can be useful, but there's almost no time when you can use a pie chart effectively that a bar chart would not have worked. And when you're having more than 2-3 categories, a pie chart can become a pain in the eye for your readers. So next slide. So essentially today we've been able to learn a couple of things about variables. Variables can be continuous, they can be discrete, and that has implications for what kind of statistical tests we'll be able to use. And you will learn more about that in the subsequent conversations. When they are categorical, categorical variables, they can be nominal, they can be ordinal. That distinction is very important because when you look at a lot of studies and you see people running all kinds of models, where those models make assumptions about the nature of the variable, where the models are essentially not compatible with nominal variables, and you still see people using those kind of models in many manuscripts, in many situations. If you've taken anything away from this study and from this conversation, it is to know that you need to know the variables in your data set very well in terms of what kind of variable are they, and that should inform your choice of statistical tests and what kind of statistical tests to avoid. The second thing we've learned is that beyond knowing our variables, sometimes variables are not just single variables, they are measures. And what that means is that you're combining more than one variable into forming an entity. Sometimes it can be ratio measures, sometimes, and it can be ratio measures, but there are special cases of ratio measures that we usually have in epidemiology and statistics, and those can be proportions or they can be rates. A proportion is essentially just a ratio where the numerator has to be related to the denominator. It has to be a portion of the denominator. While when we talk about rates, the denominator is a time measure. And from there, we've been able to go on and talk about, different, graphical displays and some of the principles. Ensure that your graphs tell the story that they should be telling, and ensure that you're matching your graph to the kind of data you have. Histograms are good for your continuous data. Your bar charts will be your fallback option when you're dealing with categorical data. Congratulations, I want to thank every one of you, and I hope you're going to stick on, and because all the things we're talking about now would not be useful until you start listening to the subsequent lectures and see how these concepts influence what kind of statistical tests are valid for your analysis, and how you should approach your statistical analysis. Thank you so much, and you're very welcome.
Thank you. So if any people who have questions can stay on, we'll take them. Thank you very much for your patience. I know we started 2 minutes late and then we went over. Hopefully next classes we'll not have to go over, but yeah, so if you have questions, please stay on. We'll answer as many of them as we can. Thank you very much. Look forward to look out for our emails and further instructions on participation in the other sessions. If not, I have a question.
Yes, I do.
Okay.
Okay, so my question is about the rate when it was talked about here.
Okay.
So my question is, you mentioned something about some of the study participants being dropped, probably because they've gained immunity or they died, and then some of the participants stay throughout the period of risk assessment. So while you are reporting your study paper, are you going to include those people that got dropped? And if we are going to include them in our study paper, how are we going to present it?
Well, that's a very interesting question. That's an important question. So that question is talking about the incident rate, about the comments I made when we were talking about the incident rate. So, of course, in this class, I'll not be able to give you a definitive answer that would work all the time. Like I said, it depends on the question you're asking ultimately. You know, whether who to include and who to exclude is a very important topic when it comes to study design and when it comes to statistical analysis. It always depends on the question that's of interest. Now, what I was alluding to when I was talking about incident rate is that there are times when the extent, you know, when how much time a participant spends in the study has implications for the inferences you draw. So for instance, let's say, for instance, now, we're comparing whether we're comparing certain vaccination types in two populations. So in one population, you are giving them one kind of vaccine. In another population, you're giving them another kind of COVID vaccine. In population A, when you give people your vaccine, okay, I mean, you give in population A, you give people when you vaccinate people. Some people got COVID and they got out of the study. I mean, some people after they got COVID the first month, the immunity waned, they got COVID again. The point here is that, and then there's some, okay, not even, and then there's some people who got COVID and who got COVID in the first month and then died. Now, when you count, so usually the way we do in vaccine studies is that you don't just, you count the number of times that somebody got COVID. So sometimes somebody got COVID 3 times during the study period. Somebody got COVID 4 times during the study period. Now, here's the problem. If many people who got COVID, for instance, in population A got COVID, and many people got COVID in January, most of the people who got COVID actually died. Now, in population B, most of the people who got COVID did not die. In population A, because most of the people who are in the study stayed through the study for up to like 6 months, the likelihood that you would have more and more cases of COVID coming up is very high. In essence, because the patients in that study contributed so much patient time into that study, they remained at risk in that study for so long a time. It is likely, I mean, the way you think about the number of COVID cases that you count in that population should be different from another study where, you know, in the first month, most people had COVID. Out of all the people that had COVID, everybody had died. If everybody had died, there's no opportunity for them to even have subsequent COVID cases down the line in that population. So in essence, there are studies where it is not just how many patients you have in the study that matters, but how much time that people remain at risk in that study, meaning that the number of patients matter, the time that the patients are able to spend in that study matter. And in those kind of situations, the incident rate might be a better measure than some of the other measures that do not take into consideration the cumulative patient time that you have in a study. I think you're going to understand this more as we take subsequent lectures.
Okay. Solomon, you want to ask Solomon?
Yes, please. Can you hear me?
Yes, we can.
Absolutely.
Thank you very much for this lecture. My question is just on clarification. Actually, I quite understand everything that you said, but for the terminology, you made mention of cumulative incidence. I've always known incidence as a terminology. Is this the same thing as incidence on its own, or cumulative incidence is quite different? That's just it.
So, incidence essentially is, you know, the number of new cases that you have compared to the population. Now, the problem, I mean, so there are times where you're conducting a study where we're thinking about different time periods. And that's when we're essentially talking about cumulative incidence over, you know, over different time periods, over a variety of time periods. So there are circumstances under which incidence would be the same thing as cumulative incidence.
Okay, are you saying they could be interrelated, interwoven? Like in some cases, I could because to me, incidence is number of new cases over a specific period of time. While, as you say now, like cumulative incidence could be new cases like over a period of time. So are you trying to interchange them, use them interchangeably, or I still don't get?
So in many circumstances, you would use them interchangeably, and that would be accurate. But there are specific situations where cumulative incidence would be a more appropriate terminology than say just incidence. So
okay.
So I think I would leave it at that. I think I would leave it at
that.
No problem.
I should also say that the cumulative incidence is also known as the incidence proportion, right? So the key thing to note here, like that you're saying that incident cases is the number of new cases, but then in this case we're talking about the cumulative incidence, which is also the incidence proportion. So it's the number of new cases divided by the individuals at risk. Do you get it? So that's sort of the nuance that Dr. Motar is explaining, if that helps.
Yeah. All right. Thank you.
Okay. So, Nuhu, you want to ask a question?
Good day, sir.
Yes, please.
Yeah, I think I've gotten the explanation. I wanted to ask on that cumulative incidence and incident too. I think I've gotten the explanation.
Okay, that's great.
Thank you very much.
Thank you. Okay, Chukwu. Sorry, I accidentally unmuted you. I accidentally kicked you off again. Okay, Chukwu.
Hello, good evening, sir.
Yes, please go ahead. So.
No, please, it was a mistake. I'm sorry.
No worries.
Yes.
Okay. What's in Marvin?
Well, okay, thank you so much, facilitator. My question goes to the slides of the scatter plots. From whatever I saw there, it indicated that the scatter plot is used to show relationships between continuous variables. So my question is, can it be used to show relationships between variables that are discrete? And would it make sense anyway if you used, because I can see from the top here, the scatter plot is used for visualizing the relationship between two continuous variables. What if the variables are discrete? And if you use that, would it make sense? Thank you.
So the short answer is that no. Where a scatter plot would be advantageous and appropriate is when you have continuous variables. And it's when you are trying to look at the relationship between two continuous variables. And when you look at some of the advantages and properties of a scatter plot that I talked about earlier, is that it gives you a visual impression of what, of how correlated these two variables are going to be, and what is the direction of the correlation. So when we're talking about correlation, actually, we're talking about continuous variables. We're talking about continuous variables. That's a measure that we compute to compare continuous variables, not discrete variables. So essentially, if you're going to do something that looks like this for variables that are discrete, what you would essentially have is a bar graph.
Right. It's just best for continuous variables because, when you actually try to see that it's continuous variables are best. So scatter plots are best for continuous variables, unlike with discrete variables. Some people use it, and sometimes you can get away with it, but